All right, let's jump right in. Today, we're talking about something pretty incredible, how AI and other cutting-edge tech are turning one of the world's most dangerous jobs into one of its safest. But before we get to the cool tech, we have to understand the stakes. And the stakes are incredibly high. The construction industry consistently has the highest number of fatal accidents every single year. And what's really sobering is that number isn't going down, it's actually growing. This is a massive problem that needs a revolutionary solution. So, to find that solution, we first have to ask a simple question. Why? What makes a construction site such a danger zone? I mean, think about it. A construction site is basically organized chaos, right? It's a constantly changing puzzle. You have multiple teams, heavy machinery, huge vehicles all interacting in a space where the layout can literally change from one day to the next. That's why the traditional way of doing things, relying on one safety manager's experience, just can't keep up. In an environment this complex, even the absolute best expert is going to have blind spots. This is where it starts to get really exciting. What if we could give those safety managers a kind of virtual crystal ball, a way to see and prevent accidents before they ever have a chance to happen? The foundation for this crystal ball is something called 4D BIM. Now, you've probably heard of 3D models of buildings. Well, 4D BIM just adds that fourth dimension, time. So you don't just have a model of what the building will look like, you have a simulation of when and in what order everything gets built. It's a huge step up. And then you bring that model to life with agent-based modeling. Honestly, the best way to think about it is like a super realistic video game of the construction site. Every worker, every truck, every single crane is an agent that has its own set of rules, tasks, and behaviors. And then you press play. And it all comes together in a really simple three-step process. 1, you set up the virtual site using that 4DB model. 2, you run thousands and thousands of simulations with all your digital agents running around doing their jobs. And 3, you analyze all of that data to spot the risks and then design them right out of the project plan. And this right here is a look under the hood. You can see how the data flows. It starts on the left with all that 4D BIM info, the layout, the schedule. That all gets fed into the middle, the simulation engine, where all the virtual chaos happens. And what comes out on the other side is a super detailed risk analysis, pointing out exactly where and when bad things are most likely to happen. And here's what it actually looks like in action. Every one of those little figures is an agent, just following its programming, moving materials, operating equipment, and interacting with everything else in this virtual sandbox. The system is essentially running countless safety drills, finding every potential problem long before the first real worker even sets foot on the site. The final output is just awesome. The system spits out these hazard heat maps. The red zones show you exactly where the highest concentration of dangerous interactions is predicted to occur. For a safety manager, this isn't just data. It's practically a treasure map for preventing injuries. Now, that proactive approach is totally revolutionary, but it's really only half the story. What if, on top of looking forward into the future, we could also look back and learn from the data of every single accident that's already happened? This brings us to the second pillar of this AI revolution, building a predictive safety engine that learns from history. So to get this, you just need to understand 2 key terms. On the left, we have attributes. These are the conditions before an incident happens. Think of them like the ingredients for a recipe, things like working at height or using a power saw. On the right, we have outcomes. That's the result of the incident, the injury type, how bad it was. The AI's job is to figure out the connection between the ingredients and the final dish. So let's meet the second piece of our tech puzzle. This is an AI that basically acts like a safety expert with infinite experience, someone who has read and perfectly memorized every accident report ever written. How does it do that? Through natural language processing, or NLP. It's the magic that lets a computer read and understand human language. So it can go through thousands of unstructured free text accident reports and automatically pull out all those crucial attributes and outcomes. It can spot patterns across a massive amount of data that a human could never, ever hope to see. Once it's pulled all that data, the AI uses a whole toolkit of powerful machine learning models. You might recognize some of these names: Random Forest, XGBoost, Support Vector Machines. Don't worry about the jargon. Just think of each one as a different kind of specialist, analyzing the data from a unique angle to find the most accurate patterns. Let's just take a quick peek at one of them, the support vector machine. Imagine plotting every single incident on a graph. The black dots could be severe injuries, and the white dots are just minor ones. The SVM's job is to find the single best line, they call it a hyperplane, that perfectly separates the two groups. Once it finds that line, it can predict which side of the line a new situation is likely to fall on, basically classifying its risk level.
So, does it work? Oh, yeah. The results are pretty stunning. The main thing to see here is that these AI models are way, way better than just a random guess. If you look at Random Forest, it predicted minor first aid cases with almost 85% accuracy. That's a massive jump. For the more severe cases, XGBoost was the best performer. The takeaway is simple. The AI can absolutely learn to spot the warning signs.
So, what happens when we put these two revolutionary ideas together? Well, we get a real glimpse into the future of workplace safety. And this really illustrates the new approach perfectly. On one side, you've got proactive simulation, our virtual crystal ball looking forward to design out hazards. On the other side, you have predictive learning, our AI historian looking back to recognize the ingredients of past disasters. They're two sides of the same safety coin. This right here is the whole ballgame. For decades, safety management has been reactive. We investigate accidents after they happen. This technology flips the entire script. It allows us to be proactive by simulating the future and predictive by learning from the past. We're moving from reaction to prevention. It's a total paradigm shift.
And that leaves us with a final, fascinating question. We've seen how AI can fundamentally re-engineer safety in construction. So if we can do it here, on a chaotic building site, what's next? Mining? Manufacturing? Logistics? The potential to save lives across so many industries is just immense.